he's the man, probably he's the only scientist who was working at the time of Corona. And I can see some of the technology that he has developed. There is a touch-free hand wash system, that's a licensed technology. There's a touch-free sanitizer dispenser unit. Besides that, he has developed many technologies. Probably he will be showing in some time. And he has published so many research papers, received so many awards, and he's also having some experience in John Deere company. So probably, when we were searching for this lecture, he was the only man who came to my mind. Very young, dynamic, and you will see the kind of work he is doing. And what I am expecting from this lecture is that, so we started that robotic car concept. Now you have to conclude it. So at the end of this lecture, there might be some of those, robotic car system, they might be, roaming here. So with this, I would like to request Dr. Syed Imran to go ahead with this lecture.
So very good morning to all. So, how you are feeling, class? Comfortable?
Yes.
Yes, I am not going to bore you. So rather than I try to give some of the videos in the slide, okay? So anyhow, whether I want to have your introduction, if you are bored giving of introduction so many people. So let me go class directly, or shall you give introduction? Just your name and degree. Last. Okay, then that's good. No problem. So enjoy the class. You don't take any. If you understand, you ask me question. If you don't understand also, no problem. If any help, you can ask. So slide is system. So as told, I myself Dr. Syed Imran, scientist from Central Institute of Agriculture Engineering, Regional Station, Coimbatore. So this is the only regional station of Central Institute of Agriculture Engineering in Bhopal. Okay, it's belong to CIAE. So here we are going to see introduction, precision agriculture related and sensor actuator used in this autonomous system and unmanned ground vehicle and development of unmanned ground vehicle. That is what actually we need this in class. Okay. So have you taught anything related to precision agriculture before class? So anything you can put up? Anything you can say about precision agriculture? So okay, no problem. I will just go ahead with the cost and everything. So mechanization might be all told you. I don't want to again bore you. Okay, automation. Of course, there is a mechanization was taken part from the animal power to the machineries. Now the thing is that we have to go ahead with the machineries to the automation. That is nothing a machinery, mechanic and the electronics. That is mechatronics. We have to move ahead because maybe some part of place we are not having much mechanized, but even though we can go ahead with mechatronics directly so that we can improve the yield. Okay, so we go ahead. The problem of automation comes. Why it needs is the main problem you all be knowing. Of course, in Jammu and Kashmir there is no labor problem. I feel like that because when I was roaming yesterday, I faced so many laborers are available. But what happened in other part of the country is that, please anybody? Tell me. Okay, no problem. So what happened in other part of the country is we don't have work laborers. Okay. So what happened early? The one farmer was feeding something peoples like 10 to 20 people in 1947 when we got independent. So in 2000, the report is saying more than 100 people are dependent with one farmer, not one farmer family. Okay. So what is going to happen is 2050. We are supposed to feed one farmer is supposed to feed more than 1,000 people. So here we are. We have to something to introduce, like when we are introducing the animal power to the machineries like that. Okay. So this is what I like to say. So automation is just we can say that is the minimal work of the person. So we can reduce the human assistance minimal, or with or without it can be taken as an automation. Okay. So precision agriculture again. I come here. Maybe you have learned. One thing I like to say is whether they have till 3 right or 5 right. I want to like that. How many right they tell? Right times? 6. What is the 6th one? Right genetics. Okay, that's great. It is updated one. But only what I like to tell is the engineering we don't have genetics, right? So here I am coming with 25, and genetic is newly added one. Okay, last class Syed might be told you, right? Right. Okay. He is very good in farm machinery. might be taken good class for you. So of course you have learned this, then shall I move ahead or shall I take deeper inside this? Sir told everything, right place, right place?
Yes.
Okay. So the technology now, maybe using this precision agriculture, we need a different kind of automation, so which is possible. For example, the GPS is the one way where we can have soil sampling, soil testing, everything. So what early system, even for the genetics or for the research institute, they do, once the sample was taken in a particular field, they will be marked. So after some time what happened, they again go to the field, but what happened, it may be mismatched. Maybe some person, some animals may be taken that marked place to some other place. So TGPS is a very good system where you will having where it has taken the soil sample. Even after 50 years, you can get where the sample was taken out. Okay, so that is the advantage of the DGPS. So we will have later everything detailedly. So I will give just a glance so you will not bore. Okay. So tillage, of course, we will have a tillage and variable depth and variable rate of tillaging and planting. You might have heard variable rate applicator. Whether anybody told you? Yes, yeah? You have learnt then. Then I will go ahead. So variable rate applicator is nothing but a pesticide. The recommended rate only will be given to the crop. Okay. For example, if I say the plant need NPK of this much rate, by knowing the sampling the same field with the use of GPS, that much rate we have to apply there. So it can be done with a variable rate nutrient applicator. So similarly for pesticide, variable rate pesticide applicator. Similarly for sowing. So all this variable rate application comes based on your need so that it can reduce the input. That is our main objective here. Of course, it should increase our yield. Okay. So here the main thing in precision agriculture comes means we have to have some electronic things in the mind. So sensors, actuators, microcontrollers, programming language, and everything is there. So sensor means, of course, this class is related to selection of sensor actuator for your application, right? So if you first of all thought of sensor, you should know what sensor for which application, right? So for example, I am telling you for spraying. So spraying means what you have to do? You have a sensor to spray on the crop, the system to spray on the crop. So the crop should be sensed first, right? So then after sensing, it should have a system that to spray the material. Okay. So the sensor first you want to know which kind of sensor you want. You are having ultrasonic sensor, you are having IR sensor, proximity sensors, lidar sensors, radar sensors, and like that you have many sensors to have to be used in agriculture, and majorly used, these sensors are majorly used. Okay. So again, how much power we need? So you are having a 12 volt, 5 volt, 7 volt. So again, the power factor is important in the sensor, because in autonomous vehicle you are not going. So of course you are not going with a one sensor. Okay, you will be having multiples of sensor, camera system, radar system, hydrospectral cameras like that. Okay? So here the power management is another important thing to be kept in mind while designing or selecting the sensors. Okay, and apart from that, we will go for actuator. I have an example so that you will be knowing that how it is working. Actuator, mostly in our agriculture field, we are using DC pumps. So most of the system, when you go for autonomous vehicle, it will come for DC application. Okay, not AC will not be worked there. So we are going to have a DC supply system. Okay. So autonomous vehicle is nothing but your DC motor, pump. You might have seen some of the motors in your early class DC motors, and also some of the pumps. There are many things, solenoid valves, and also linear actuators, linear solenoid. Whatever things I am telling is I used personally, and these are very much needed for the application of agriculture. Okay. So next is that we have controllers. So controllers, of course, you have used Arduino. You know, right? Yes. And also there is other advanced. When Arduino is a simple hardware which is having both hardware and software. For building block, initially you are going for any building block. Rather you are going for each digital pins, analog pin, USB cable, Atmega some microcontroller and everything. You can have a ready-made system where you can use it and you have reduce your time and go to the. So for any autonomous vehicle you are developing, always remember. Take it what is available. So our part is not to develop any sensor. Agriculture engineers are not to do any develop any sensor, but it is very difficult. It's not that much possible. Of course, it is possible to do that, and we have to only integrate the system. For example, there is a sensor, very good sensor working, and there is a microcontroller with libraries. Programs are also available in the internet. We have to take that, and we have a very good actuators. So all together we should put it and should work for our agriculture purpose. And if you see GPS is already there for more than 50 years, and that is they kept for only military purpose. Now they are giving it to civil purpose, and this is a very good gift for agriculture. Okay, so early we can't go more than 50 centimeter accuracy. Now we are going to get more than 10 centimeter accuracy GPS. If you have DGPS is nothing but you will be having a base station where any error will come, this base station which is already GPS number is there will correct it. So your accuracy will be again increased with the using of DGPS system. Now again the RTK GPS is coming. Whenever there is a dynamic move or kinematic move of the vehicle, on the fast of the vehicle will get very accurate data. So everything will tell later. So Raspberry Pi, which I want to tell. So Arduino, I told, Raspberry Pi is another computer, your computer similar like laptop. When you are going for higher rover, autonomous rover like that, for example, we are sending rover to the moon like that. When you are going advanced like that, we should have advanced system. Then you can actually, you see one autonomous vehicle having more than 200 controls. Okay. So for that Arduino kind of system will not work. Then we should have a higher version of that. So we should have Raspberry Pi and advance of that. So these are the controllers and programming language. Of course, in Arduino you might have used C++, correct? So in Raspberry you will be having Java. The very user-friendly one is Python. That will be like we are discussing. So very user-friendly. Only thing we have to make first step and other steps of going upside will be easy in Python. So Python is a very good software. Possibly you can learn it. And simple electronics possibly you will see. So this is our precision system which I was telling. So mostly in precision system you will be having sensing, that is something to sense to measure it. So that is the measurement sensor I am giving here, and controller, and the controller and the programming language is your management sector, decision sector, and your management and analysis sector, and your decision will be your actuator. Okay. So sensor. Have you learned anything about sensor? Anybody teach you before class so that so ultrasonic sensor, how it works and everything they told you?
Yes, sir.
Okay, then better. So how it is working? Anybody can tell? Yes, come on. Yeah, okay, no problem. I will just go ahead with one piece, so you will recall yourself what they told, and so you will get more information on that. So what happened in ultrasonic sensor? The high frequency wave will be transmitted, so which is not audible to the human. Okay, so that will be strike on the any object it may be. It will strike and return back to the receiver side. Okay, so what happened? This they might have using ultrasonic sensor. They can have distance. They can have n number of applications. So you can tell one or two after after this introduction. So what happened, the distance, the time taken for the distance and the time is into 1.2. That 1.2 is nothing but you are sending and receiving. So that is half. So it is nothing but half of time into distance. Okay. So that you will get how much distance you can calculate. Okay. So you can tell one or two applications ultrasonic. So most of them have told you using ultrasonic, because without ultrasonic agriculture automation will not be there. Okay, then one or two applications where we can use. So I can relax myself for 1 or 2 minutes.
Sir, object detection.
Very good. Excellent. Then you can say in application point of view where in agriculture it can be used. Definitely you have learned. If they have told you ultrasonic, there will be an example they have mentioned you. Right? So okay, no problem. I will tell. If you want to have a water level in the well, or if you want to have detection of plant, detection based spraying system, so there your ultrasonic will be working. So like that you have a n number of things, you just recall it where you can work. So I will show some of them. Maybe in your class you have seen some of them have told you. So this ultrasonic sensor is what kind of sensor? It is non-contact type sensor. Always remember, there is a contact type, non-contact type. Can you tell any example? Contact type sensor? Any one example? So limit switch, okay, limit switch, which is the contact type. Limit switch is nothing but our switch. Manual, we are on in the panel. So any system works on contact type, that is contact type sensor. These all things are non-contact type sensor. So of course these all are proximity sensors also. So this proximity sensor, IR sensor, PAR sensor, all are considered under proximity sensors. Inside proximity sensor there is the inductive sensor, capacitive sensor, electromagnetic sensors. So what is difference? I will say just a small difference. The ultrasonic sensor is, first I will say proximity sensor. Proximity sensor is comes under metal detection. It will emit the electromagnetic field. Okay, it will give the electromagnetic field where any changes in any metal comes in contact with the sensor. There is a change of electromagnetic field. Okay, so that change it measures based on that the proximity sensor works. And the IR sensor is your light. Okay, light pulse will be sent off. When again like it is like a ultrasonic wave sensor. There is a transmitter, there is a emitter. So transmitter LED light will be passed and the return back transmitting will be our light signal which is received. So based on that, but IR sensor has a very much drawback. Can anybody say why we can't use IR sensor in the open field? IR sensor works on light, right? So your light intensity varies, then the performance will vary. So that's why most of the time we go for ultrasonic with very close wave, but in high wave we go for radar sensor okay. So these are the things. And PAR sensor is also infrared sensor that calculates whenever we are having some temperature, right? So the sensor will be emitting continuously some infrared rays. So whenever the person comes in that radar, in that position, there is a variation of temperature, right? So in that way, PAR sensor. Can anybody say, because here it is very important, PAR sensor is very important for German gas. Can you anybody say one application where it can be used? It is used to detect any person is coming, moving and everything. So it can be used in fences, right? For example, your campus fences, you can have it. So any movement, it can give up to a range of 100 meters. So any wild animal entering your campus or any field, you can use PAR sensor. So it will make your alarm or some other things, okay? So that even now the things are there is a gun kind of thing, stone gun kind of thing, so it will throw exactly to the position. We can think of drone, small drone, which can make wild animal to go ahead of that. So these are the ideas, not work for anybody, but I am telling you ideas. You can thought about it like that in your future, okay? So radar sensor. Again, the radar sensor is a very good one. Mostly all the Chandrayaan they will be a radar sensor. So this is a light pulse working system. It works very well. It will have a range of more than 1 kilometer. Okay. So moisture sensor you might have learned. Moisture sensor how it is working. There will be a one is positive and another is negative. When the water is present on the soil, there will be a conduction. So based on the rate of conduction, that will be showing the how much percentage of moisture. For any sensor, you should have always it should be calibrated. Okay. For any sensor, even load sensor or anything you are receiving, even in your college you have taken load sensor, you will be adding 5 kg, 10 kg, 15 kg, 20 kg. There will be some value will be displaying there. So you will be noting that. So with that reference only you have having that this is 5 kg, this is 10 kg. That will be used for writing in your program. Okay. So gas sensor where it will be used, anybody can tell? So cow sheds or something like that, there will be emission of methane gases. So there you can have this gas sensor to understand how much methane rates are emitted and how it can be manipulated and it can be capture the gas and the emission to the atmosphere can be neglected. Okay. So temperature sensor. So you for temperature, humidity and all you can use for weather condition, also for any greenhouse system you can keep inside that and you have an idea of that. So you are all agriculture, then it will be useful for all, because for any research you will be having or you are doing noting the temperature, weather condition and everything. So these three are very common to all. That is temperature, relative humidity and the wind speed. So all three can be used with the, we should have anemometer for knowing the wind speed of the or lower speed of the that greenhouse structure. Okay. So some of the system I given here because I came to know some of them are vegetable science, fruit science also. So I thought some of the slides can be included here so that you can where can this sensor can be used in your field. Okay. So you know now that research is highly intensively going on electronic nose. Some kind of rattan understanding gas they can predict and they can have that one. That kind of sensors are going and spoilage rate understanding sensors are going. Okay, these sensors can work all whatever the basic sensor I have told, right? The gas sensor, temperature. Based on temperature, your fruits may be having some range. Based on that, you can understand the spoilage of the fruit. Again, the gas emission from the storage, cold storage, the gas emission. Based on that, something is transporting from here to somewhere else. For example, apple in our place, that is, I am surprised to hear apple rate is 50 rupees per kg. In our place, it is 250 rupees. So I am taken 5 kg of one box. Okay. So what else? My family told actually, hey, it is good. Then you take and come. I took extra day. So what happened? The main most of this problem, why this rate difference is coming? You know, this spoilage is more. Most of them you are transporting there, your 30 to 40% got spoiled. So of course their rate will be there. That is the reason. There is no other thing. Maybe that is one of the main reason. Okay. So for there you can have some spoilage sensor, gas sensor. There it can automatically, similar to our car climate control system, can be installed. So it can be used like that. Okay. So I come after sensor. I come apart from this. I also like to say some of the sensors also. That is color-based sensors. So based on the color, you can see what is the ripening stage of. For example, apple you are having, there will be a different color over the growth of maturity of that fruit. So you can also have some color sensor, RGB based color sensors. Okay. So again, similar like our load cell, what I told, moisture content I told, there will be a value, calibration values, and that you can be intercorrelate, and you can say, yes, this is completely ripened, this is not ripened, this is affected by some disease or pest like that and all. Even pest effect or nutrient deficient also you can have. The camera is a very good one, depth sensor camera now. All the autonomous vehicles they are including to understand. Based on that, they have be processed for image processing, and based on image processing in grayscale, they will be having what is the what is the infection, maybe a pest or nutrient deficient like that, water deficient like that. Okay. So I told some of the sensors, many of them are there. Next, microcontroller. I have already told about this. So you might also be knowing, and I am going ahead. So microcontroller, you know, is very commonly used. Now nano is also using for small size because of the small size, and they will be having so much storage power. And Raspberry Pi is your small computer. So all your IoT systems, they will go for Raspberry Pi because you can have you can send the data to the cloud, and you will have multiple data in your mobile or your place like that.
They have already worked on Arduino.
Yeah, that's why I discussed it. Then I told I will not go deeper on that. Okay. Okay, actuators. So mostly used actuators in our agriculture system. So mostly I am telling this because you will be having any of this application in any of your project if you are going for precision agriculture. Even you are an engineer, even your agriculture, even your horticulture. These are the only idea I am showing to you. That you will get, yes, this was taught, this can be happened in some way, okay, and you can discuss with engineers and you can make a better way. So always research should be with us, not a single discipline, it should be a multiple discipline to get a fruitful result. Okay, so that's why I'm giving giving ideas what are the things are actually present. So I will give some our work what we did with using this all sensors and actuators also. Okay, so water pump, most of the spraying system. You will be having this for the two variable rate spraying system or direction based spraying system or smart spraying system. Whatever you say, which are having electronic components and working, they will be using the DC pumps. Okay. So here the advantages of this system is you don't want to have so much of big size of pumps or anything like that. It can be multiplied and enough pressure can be produced with using the DC pumps. So wiper motor is generally a DC motor. Why it is called wiper motor? Anybody can say? So it is not actually the wiper motor is not a technical term. It is motor, DC motor. Wiper motor because it is used on our car, right? So it is a wiper we have seen, right? So the same thing is a wiper motor. It will be giving some angle, 120 degree, 180 degree like that. But this torque is very high. We can use it for autonomous vehicle steering control. You can use for wheel controls like that. So like that we can use wiper motors. Solenoid is again used for spraying system or in food processing. You can say for drying system or wherever you want to inject some chemicals. You can bring a solenoid into picture. Your predetermined amount can be sprayed in that position so that you will achieve what you actually want. That is the solenoid. This is also 12 volt and 5 volt both are available. Okay, 24 volt also available. Solenoid linear actuator is again as like a solenoid pumping system. So linear actuator, I am coming here. It is very good application in the agriculture field. So most of the agriculture vehicles you see, you will be having a lever and you will be having a steering. So wherever the lever is there, you can use this even this linear actuator and this linear solenoid. The only difference between the linear solenoid and linear actuator is linear solenoid will give immediate push. Okay. For example, you want to 5 cm push, it will give immediate push. 10 cm push, it will give immediate push. You might have seen in Discovery Channel, maybe in the processing field, where the bottle, Coca-Cola, Pepsi bottles are coming, they will divert it, right? So these are, they are using the linear, the solenoid linear actuators. Okay, this one, solenoid linear actuator, where you will get 5 cm, 10 cm, 15 cm, 20 cm, whatever it may be. But when you are going for higher centimeter, the cost will be double, triple, like that it will go. Okay. So linear actuator, again as I told, it will be used for all your small. The only disadvantage of that one, this one I will tell. This will take time because this is screw movement and the torque is very good compared to that one. Here you will be having 2 mm. 2 mm, can you understand? Very small amount per second. So for example, you want to make some push of 20 mm. How many seconds it will be needed? So 2 mm per second means 20 mm. How many seconds it will take? Okay, so there you will get a second push. Okay, so that is the difference here. But the torque of this one is higher, 10 times more than that one, because it has a control. Similar like our machineries, where the speed is reduced, the torque will be increased using the gear systems and everything in tractor. Okay, so DC motor, stepper motor. So these are used. Stepper motor most of the time we use it for wheels. And variable speed, wherever you want variable speed, wherever you want programmed speed, wherever you want planting metering mechanism, there we can go for stepper motor. And DC motor is ordinary one. We don't. We'll see some of the example on that. Okay. So here some of the example. Whether anybody shown you a deduction based spraying system? So maybe this may be a same. If you have seen that video will run. Can I reduce the sound? It's possible to reduce the sound. Okay, is that visible?
Yes.
So this is just, we did a small work with our BTech trainee students. So what we did actually is, we want to spray only on the crop canopy or the crop. Okay, so we don't want to spray in between the crop where there is which is not our target. Okay, so what happened? This system we have developed like that, only to spray on the canopy or the crop. Okay, this is just not an exact model. This is a model. Okay, keep this not a exact prototype. This is a model. So where the crop is detected, only that place it will be spraying. So in between the two places, there will not be spray. For example, if you are taking a 10 meter of length of crop row, you will be having 90% of the area where you no need to spray. So for example, I am telling again in another way, 10 meter of the spray you have to make, 9 liter will be waste in between the two crops. So why you are wasting your input, chemicals, even nutrient you are spraying. So that are so much cost. That is why precision agriculture comes into role. Here you are reducing your resource and increasing the yield where you want to target. And also while training also you are continuously spraying, nobody will go to stop. So here when there is no detection, then exactly it will stop spraying. Okay, that is the advantage of this system. Okay, but little bit I go ahead. So what I did here is actually I made, it is not possible to make constant speed of tractor. I tried to keep constant speed of tractor so that at detection, once it detect, after 1 second the spray will happen. But it is possible in the field because, so the speed will vary, right? Tractor speed will be varying. Even your road you are going, sometimes you are going 30, sometimes you are going 40. So your speed will not be a constant. So the thing here is the first one which I shown the spraying system, that is this one. So I made approximately tractor to go in same speed and detection and the spray were happening. So what happened if a new driver is driving? I made for 1 kilometer per hour, but the new driver is driving, he is 2 kilometer per hour. You want to go fast, okay? So in fast running, if the what happened continuously detected and continuously spraying will be happen. Understand what I am telling? So it should have some system based on the speed, the spraying should alter itself. The second, based on the speed, the second of spraying should alter itself, right? So what I did is actually we include a rotary encoder to the wheel. So if the wheel is increasing speed from 100 rpm to 200 rpm, the spray in the 100 rpm 2 seconds, it will be reduced to 1 second. For example, I am telling. So that it will not spray continuously. So our purpose is even whatever speed the vehicle is going, the amount of spray should be same, the amount also adjust and the timing should be reduced. So anyhow the optimal amount should be reached there. So accordingly we have programmed it and we did it. Okay. So this program I am not going inside much. You already see C++ was taught, and if I start telling this, it will get confused. Okay. Anyhow, we will afternoon we are having C++. Some little I will tell you. Again, you don't want to type in everything. I will teach you so that it will be easy for you to understand. Okay. And the second system which I am showing is small tractor operator EPN applicator. So nematode applicator for sugarcane crop. You know, sugarcane crop, there is a white crab is there. So if it is present there, the crop will be standing very well, very good, it looks very good. If you go and touch means it will fall down. So there is a nematode which will eat all its root one by one like that. So they need a system, this is developed by us, they need a system to place the nematode EPN solution near to the crop. Okay, so see this video. So that nematode will be killed off. Okay. So this system, I will tell what we have did. Okay, no problem. So here you can see very simple system, similar to the sprayer. We are having one tank. You can see one tank. There is a furrow opener near to the crop. 2 furrow opening will be there, and 2 motor DC motor we have attached. So the 2 DC motor below this furrow opener. So whenever the vehicle start running, the signal of ultrasonic sensor will be sent to the DC motor, and it will start its pumping of the nematode solution to the soil. Okay. So whenever the tanning is happening, it will stop. Whenever that attachment is lifted, the system you made is whenever the attachment is lifted, it will stop pumping the liquid. Okay. That is our idea. So this is a very good system, very much appreciated. Actually, we don't want a big sophisticated system. We want a solution for some of the problem. Okay. So this is very simple kind of thing. So what you might have learned in your previous class also can be adapted for this kind of system. So this is just a ultrasonic sensor, pump, and only for detection system. That's all. And you will be spraying on the field.
Does that mean our students from vegetable science can also apply the fertilizer?
Yes. That's why I'm telling. That's why I'm not going deeper inside. I'm giving you idea. Even you are vegetable science, fruit science, you can use this idea. So even you can have some hand pumps. You can see in the field they are spraying something nutrient or something like that. You can have that. You can just keep on sensor, ultrasonic sensor, and some pumps, and you can just show it will spray. And we have also developed one injector where the rhinoceros will be there in the banana. Okay, banana stem. There will be the rhinoceros. So what actually the practice is that they will have a screwdriver, and they will dig on the screwdriver up to 5 to 10 centimeter inside that stem, and they will pour that chemical, taking just pouring in the. So what we did, very simple one. This will be useful for vegetable and fruit science people. We made one injector, okay? Just you are injecting if you are fever or something like that. We made an injector with one pump, prismatic pump. We have treated, and whatever the amount you want, okay, you just click the button. The spray tank, the amount of spray liquid will go to the just injecting on that, okay. So it is very useful for example, they will be injecting for 5 ml. The farmers will be injecting 50 ml. What happened to the crop and what happened to us when we are eating that one? Okay, we want only 5 ml. With the pump, we can make that how much needed it can be sprayed. Okay, so this is a simple one, injection, just injection kind of system. Okay. Okay, now I am going some of the precision equipments. Maybe this lesser level GPS operator may be lent. Some maybe Syed told you how this lesser level is working. Okay, I go ahead. This is my system. What is the actually happening is in dawn field, the rice field, we have to place urea, right? Broadcasting. That is the common practice they used to have. You know how much percentage of that urea you are broadcasting going as waste? Can anybody say how much percentage of urea you are broadcasting is going as waste? Nearly 70% of your urea you are applying is going as waste. You know, only 30%. That means you think about that. All over India we are having so much of field of rice, and so much amount of urea. Your 70% is goes, and for making that urea, so many factories, so many energy, so many pollutions happening. So there is a technique. Instead of broadcasting, it can be deep placed inside the soil, okay, to the depth of 5 to 10 centimeter below the soil. So our idea we came with while transplanting the rice. Why can't we place the fertilizer below the controlled release fertilizer? Not that is just now we are having neem coated here. Even that can be adopted below 5 to 10 centimeter in the soil. So it will be slowly released, and the nutrient needed can be have. So mostly in down field they will be having after 2 to 5 days they will be taking nutrient. So slow release will again give advantage of taking the nutrient to the plant. So this is the system. Again I am telling here I am used proximity sensor. Only difference what I used last two project and this project is sensors. Okay. So in last two project I use ultrasonic sensor. Okay. Here I am using proximity sensor. The advantage of proximity sensor is the working of proximity sensor. It will be emitting some electromagnetic field. Any metal comes in that electromagnetic field, there will be a change of electromagnetic field variation, and that will be taken up for as a detection based system. Okay. So here the same system. Why I go with electromagnetic? Because here the planting arm is with metal, and electromagnetic this proximity sensor will be giving so much accurate and very fast response. So you can see here system. You can see here the light one blinking, that is a proximity sensor where I have attached, and second one there is a planting arm. So each planting arm it is detected, the signal will be sent. Okay. So every 2 times it is detected, 1 time the fertilizer will be found. For example, you can see here dotted lines, cross line, dotted line. Every 2 times detected, 1 fertilizer round this fertilizer dropping will be happen. Okay. So accordingly we made systems, DC motor operator to make light system, and solenoid. So what I told you now that linear solenoid, that is what in the downside. You can see how fast it is going. It is not same speed in the linear actuator. So linear actuator also I will tell. Wherever I use the system, I will tell you what are the difference and all. Here you can see linear solenoid, how fast it is working. Okay. And here I have this every 2 times detection, 1 time placing of this urea. I use one timer. So timer to work for that solenoid to actuate. So timer means you can have 3 times detection, 1 time placing, 4 times detection, even 100 times detection, 1 time. For example, it may be used for food processing, packing, or fruit packing, vegetables packing. 100 numbers reached, then 1 time the box will be closed, and that it will be diverted to other side for the other box. Like that it can be used. Okay. So this is the other system. Again we have walk behind and ride on type. So this is developed for ride on type system. Okay. So this system I want to show you because it is very good even for food science, vegetable science, any department can be used. This is developed in TNAU. You can see this video so you will get idea. So you know injection syringe, that syringe with that we want to place single seed for a time. Most of the fruit science vegetables they want only single seed to be placed in the nursery trays. Okay. So this is very good method. You can see here, right? You are seeing only one seed, that is coated seed. carrot or small seeds, whatever it may be, it can be coated, and a single seed can be placed in a single seedling system. You can see how the application was taking, right? So there are many idea. You want just idea, okay? Other things you can get it. Just you can imagine each one will be having idea. You will see in this. Maybe in some field, maybe not only this video, in some other video you will be having some of the idea. Definitely I will tell you will be getting some idea, somewhere you are correlating this one and you are thinking. You know what the suction here used, your vacuum blower in your home, na? Maybe in the office or maybe in the college or airport, we have seen suction blower system for cleaning our floors. The same system was used. Here the very low cost. Nothing, you are installing the blower which is already available, you are taking the syringe from the medical shop, you are coating your seed and having a small plate like taking and just putting on your tray. Very simple thing you can use for your research or anything, even large scale. How can it use for large scale? I will show that. So there is a complete mechanization system for nursery preparation, right? So you can see here the person is putting the soil material and the same system adapted. Here then a complete this nursery will be prepared. So once the soil sample was placed on that, and like this it will fall and it will be compressed by linear solenoid. What I told, no? Wherever the sensor is coming, actually I am telling you, so that you will recall that one. Okay. You can and also see how it is applying in the system. Whether it is visible to you, smaller. Yes. Smaller. I will make pixels later. Now it is little better. You can just watch it. Next the linear solenoid will come. It will compress it so that it will settle. So there will be not porous space. Okay. I think video is getting stuck. Yeah, this is linear solenoid. I have so many videos, that's why it is there. Okay, surround it. So second it will come for solenoid valve, only once it will compress it. So after that what happens, the seed will fall. How it will fall, can you tell? So early video you saw, na? That system was incorporated in this system. It will take and it will automatically, there will be falling. That system also using the compression, that vacuum cleaner, that sucking and this dispersing system. Okay. So this is what I told. Here you can see compressing the nursery. Okay, this is here you can see it. Okay, how it is taking a fall. Here the stepper motor was used. Where that is going circular motion, there the stepper motor was used, and it is placing one by one on the tray. Okay, you can see here. Very simple thing, can be used in multiple places. Whatever your display may be, it will give you a credit. Okay. Okay, let's go faster. Only problem is if I forward fast now, it will start. Okay, after that the soil will be placed above that and it will be closed. Okay, let's go next. So this is the system you have seen, pneumatic planter. So pneumatic planter, single seed or double seed will be picked and placed on the soil. So I worked in CIAE with a DC blower. What happened actually, the system with pneumatic planter attached to the tractor is, we will be having a blower which is weight more than 20 to 25 kg. It should take so much of power of the tractor. After that attachment will come again 25 to 40 like that. It will go above more than 300 kg like that. So what we thought, you can see the another side, your right side, So there is a very simple, there is a no blower, this blower is not attachable. What we did, we made a DC blower attached to that system, and with that system, with battery attachment, with that actor, we have this system. You can see how it is working. So we have tried with different seeds, and it will be picking the seeds and dropping. You can see very good in this video how it is picking and dropping in the soil. The front side is the furrow opener. Once the furrow was opened and the seeds was picked here, of course it is cotton seed we have used. Most of the time what happens, cotton, very good spherical shape of seeds. Spherical, understand, very round shape of seeds. It will get single seeds. But what happens non-spherical? The spherical, when it goes more than 0.5 rate, in that as a double picking, triple picking will be done.
You can show them videos at a later stage.
It is inside the.
Say it is inside.
If I don't say so video, they will see. That is because I like to understand with the video. They will have in their mind more than I am telling. Maybe bored after 10 minutes of my speech, so the video will remain in their mind. That's why I always keep video inside that. But this is very, you can see 45, 1 GB like that. Alright. So far any doubt? You can say one application from your field like that.
Yes, at the end of the lecture they will be discussed.
Okay, done. So this is another system. This is another kind of system developed in CIAE. It is commercialized to Dirty Agro Engineering. It is also very good system. You can see how it is very good. This is licensed to Dirty Agro, and they have made a commercial set of unit. Have you seen anybody? Not yet. Nobody is seen. You can see how it is picking the seeds. See here, there is similar kind of vacuum system. Inside that pipe, the vacuum is there, and other side there is a metering mechanism where seeds are placed. The seeds are collected due to the vacuum on the hole created on that pipe, and the single seeds are collected. On the other side there is a cut-off wall where seeds will be cut off and poured. This is a very good system developed in CIAE. Okay. So similarly for weeding, inter-row weeding, we are having system. So you have seen intra-row weeding. Okay, inter-row weeding is very common, but you have not seen intra-row weeding. What intra-row weeding is? Between two plants. Between two rows there is a system, but between two plants is very challenging. So far it is challenging. This is developed by one of my senior IIT, where the system will go in between the two plants and it will weed and come again. Again here the ultrasonic sensor was used. Similarly for image processing, weeding also system was there. And also in between the two crops, using the hydraulic takeoff system, also there is a weeding system. So this is a similar kind which I have shown earlier, direction based spraying system. I am not going into this. And this is a granular fertilizer applicator. So initially I told, right, for GPS we are taking the location, then we are giving input nutrient or something like that. Okay. So what here they did, it is developed in CIAE. What they did is they have taken the field nutrient content of different location. They put up into the map. So you can see here map, red color, this yellow color, orange color, blue color. Blue color means the nutrient is rich. When red is come, the nutrient is less. Okay. So there the nutrients will be far high. So once this map is created, it will be fed to the system which is developed in this fertilizer applicator. Accordingly, the motor will adjust itself to follow the fertilizer on that place. For example, when red is there the that metering mechanism will adjust more to get to be dropped in that place. Okay. So it is NDVI based variable rate IOD applicator. So here NDVI sensors are used. NDVI is very much important for using, so for knowing the nutrient content of the plant by knowing its color. Okay, this system was developed and for paddy field. Okay. So this is yield monitoring. What happened for rice, for different area there will be a variation. You can see blue means that is good yield, and again red is very less yield. Why it is happening? For the understanding whether maybe there is a disease affected or nutrient deficient or irrigation problem. For understanding that, there is a system, yield monitoring system, that is nothing but when you are harvesting, the grains will be coming. Okay, it will fall on one load cell. So load cell will be recorded continuously. For example, in a particular this place we are harvesting, we are that load cell is getting 2 kg of fall. But when you are going after 10 meter, there is 1 kg. That means something is there, some problem is there. Maybe a planting system failed, or maybe a irrigation failed, or maybe a nutrient failed, or disease infected. So that kind of system, it will give the whole map picture of that field, and based on that we can predict over year, and we can say something is there. Therefore, it will be useful for research purpose. Okay. A similar kind of thing I told, the load cell will be mounted maybe in the conveyor or on the tank like that, so that we will understand what is actually happening in the field. This is soil pH sensor, real-time soil pH sensor. So on to go you can get the pH and whatever nutrient content. Now the study is going on nutrient content NPK also. So how the field and what is the nutrient content in the field can be get, and they can be mapped accordingly. You can have fertilizer application. So soil sampling using GPS, you can get the soil sample. Earlier what we do, we will go to the field for getting the soil sample. We will have that soil sampler, and we will take sample after 5 to 10 centimeter, and that apparatus will take again and will test it for the soil nutrient. Here the system, very easy system was developed in CIAE, that we will having a controlled that hydraulic cylinder will be there. It will be placed inside the soil, and the sample will be collected, and it can be taken by the person. Okay, so these kind of systems also available. So one system COVID Syed told, right? Because I kept this because it can be, sensor can be used for any field, and this is not new anything, but it is very much needed on that time, COVID time, because we don't have sanitizer, we don't have system, and in our place it is complete lockdown. So much problem was there. Anyhow, we got some time to go for office. Then we thought what we can do. Then we thought we'll do this one. So luckily, what happened on that time, from one company from Delhi, you can say Sun Enterprise, he contacted us because everything stops, but not agriculture. You know, agriculture was going because if that also stopped, means we will face so much of problem on that time. So that person told me, we want to supply for fertilizer companies. They are working even in COVID times, and also for some of the markets. So we need a system which you have developed. So we give it to us. Then later, what I developed is here, and what they have developed is here with ICR CIAE technology developed. Okay, jointly we have license to them, and he sold more than, this is very old data, more than 2,000 units in that 1 month he sold, within a month. Okay, and another system again, I thought okay, we'll go ahead with some other system. So that system and this system, the difference is there sanitizer is only there. Here water plus sanitizer. So water plus soap is there. So sanitizer, maybe some people having itching problem and something in the hand. So for that problem, to sort out that, we thought soap liquid and also water can be used. It can be used in schools and many places, in even temple. On that time they have installed, they have sold even big malls. You can see in net where he, so many places. So this is also the old one before. On that time he sold more than 50 units and within a month of time, which he is reported to us. So this is how the sensor is used. Don't think we are, this thing is different, we can't do anything. It can be used in your home, it can be even your, many of them tell hobby is different. This is the very good hobby, going to help you in many practical way. Okay, you can think of this. And this is the second topic which is going to take in afternoon, but anyway I will cover now. So what can I do?
Maybe in the afternoon session.
But I have so many slides.
Okay, then little bit introduction, and in the afternoon session they will be only doing practical part.
Little bit I will give introduction. So, so whatever I told here is sensor, microcontroller. But time is up to
10 minutes.
10 more minutes. Okay, I will take 10 more minutes. So far we have seen, you are not bored, so I can take further. Okay, then it's okay.
Well, I have kept the sensors here. They want to see probably they will get some.
And I will show afternoon by,
Afternoon.
I will keep them and I will show them later. So unmanned ground vehicle, which is our afternoon class. So afternoon we are having to going to have three sessions. The first one is remote control system. For any ground vehicle, we should go step by step. Okay. First one is remote control, and second one is autonomous. We will have some sensor. So it will make its based on the obstacle, it will make its path to go. For example, some obstacle is in front of it, it will change its direction, it will go somewhere else like that. And third one is voice control. You know, coming days we are going to have only voice. We don't going to chat and all. We don't have any problem of chatting and all. We are going to have only our voice command. Okay, it is going to play a big role, very big role. Even you can see now itself, Alexa, what we are doing. Nobody is just we are talking and it is hearing us and it is giving the reply. So that is even for child we are training. All the foreign countries they are training. But it is not safe, but if there is going on, it will going to come similar like our mobile, it's unavoidable condition, okay? So we will see that voice controlled system also, ground vehicle system. So as I told earlier, it is just a mechatronic system where we have started coming from animal to human, animal to machinery and machinery to mechatronics. And the system is always having four things. For any operation, there is a four things. One is identification the location. For example, you are doing harvesting or you are to spray, whatever it may be, spraying, harvesting, nutrient application. You have to know location. That is precision agriculture, right? Right place. You are telling right place, and you have to go to identify and locate that place, right? After you what to have, you have to detect and measure the things. So how you can measure your sensors, camera sensor, image processing using that, or your ultrasonic sensor, so that it can detect and spray there. So you will be having a detection system or measuring system. Then you should have an analysis. What is analysis here? You will be having a microcontroller which do that work, and your computing softwares, which is your program which you are feeding inside, right? After that action, what is your action? That is your actuator. So I made like that, you will understand from beginning. So now it will not be have any problem. I'm not going inside complicated things. So this is the whole structure. Okay. So for any robotic arm, we will assign these four things, is major one. So you can see here, first one is imaging and sensing, that is nothing but sensor used, and also decision and analysis things, and some platform will be there, right? Something was used and it will be action will be given by the actuator. So for building unmanned ground vehicle, okay, so these are the important things: hardware, environmental, performance indicator. So okay, it will take time, but anyhow I will complete 10 minutes. So platform, you need some platform, right, for making autonomous vehicle. Huh? In that, no, we should have these three things: platform, transporter, operation functions and all. So platform earlier was there, your tractor and the power reader. Now it is an autonomous vehicle going to come like this. And your transporter is nothing but your wheel, track. For example, if you are going for wheel, you will not it will not be useful for soft soil. Even if your rain comes, your tractor will not go inside the field, right? So there we want track type system. Track type system, can you give one example which is having track type system for any operation like that? Yes, exactly. Why mini combined track? There is a track. Can you tell? Why that is? Why there is not?
Very topography, it has to go there. Na?
Yes, of course that is correct. So we want for soft soil, we want a hilly terrain, even for rain condition it will work. So we want different transporters are there. Maybe track type or a wheel type. Now it is coming. You might have seen in the Asia Cup they have introduced a dog kind of walking robot, right? So these are different platforms. Maybe I remember yesterday I was going to that what is the place? Boysarana, the Pelgam. I was going with horse. Then I remember that Asia dog kind of thing they are doing. That much of balance, I was thinking I will fall in some place. But that much of control I am seeing, I was amazed. Oh, so far I have not had that kind of experience. So I really experienced very good yesterday. But similar kind of system also emerging coming today. Okay, why I am telling is that kind of transporters also available. Okay, that's why I am mentioning here. So operation function is nothing but your controls, steering, lever adjustments, brake, accelerator. So all these also functional. These systems are needed in the platform development. So for any autonomous vehicle, you want a platform. So for platform, these things are needed. Which one? There is need a platform. So for example, here the platform is chassis, and there is a transporter, wheel or something like that, and operation system for forward, reverse, and everything operation. Okay. The next thing is communication. What is this communication actually means in robotics? Okay, is that it has a two types. One is internal communication, another one is external communication. When the device element in the system communicate itself. For example, I made a sprayer, right? So that sprayer, what happened? The sensor is detecting, and that information is going to the microcontroller, and spraying is happening. This is internal communication. Within it's happening. So what in that map-based system I told you, some map-based system where the nutrient deficiency was recorded, there red color, blue color is coming. So that is the external communication. Can be used for external communication. That is, once the deficiency was recorded, it will send the report to other system. That is nothing but the device and element communicate with others, other tractor or other system. That is external communication. So inside I am talking, you are hearing. That is internal. I am talking, and somewhere from online he is hearing. That is external communication. How? It is the by internet we are connected. Similarly, from the vehicle it is connected to the other vehicle. That is external communication. That's all. Very simple. Okay. And sensors. So I will move first. All these things I have a little bit covered. So internal, external I have told. Okay. In sensor part we are having different position sensor, altitude sensor per vehicle. If you are going for robotic, I am talking here only for robotic vehicles, so that I am not going again from beginning. Okay. For rover you want means you want definitely you needed a TGPS system. Okay, position system where you are. That is needed for, otherwise it will go somewhere. Then we have to bring it, come here, come. We have to take that. Okay. So position is very important for that. And second one we will be having that altitude. Okay. So maybe in our ground vehicle it's not a very big one, but we needed for trajectory where it is moving. For that we need a altitude sensor also. But drone it is compulsory needed. Okay. So where which height it is running. So altitude sensor also needed. And apart from that, safety sensor. So safety sensor, can you give one example which can be used? Safety sensor is nothing but anything you can use it, that IR, ultrasonic, radar, whatever I told. Na? Anything is safety sensor here means nothing but it is some obstacle will come. Okay, what your vehicle should do? It should stop. Or second option, it should detect itself that to have free space. It should go somewhere. It should go. There is a, so for that purpose, you should have a safety sensor. Okay. So other sensor mostly in autonomous systems are camera. Image processing, based on image processing, hyperspectral camera they will be using. What happens means in between row it is passing. It will take the plant, by processing that it will analysis and it will go itself and take 10 and it will have. LiDAR sensor is very good example. It will detect the place, and also it can give the, for example you are having some plant rows, it will take all the plant rows, how it is there and how much depth it is there, how the diameter of that. Like that, everything will be given. LiDAR sensor is a very good example for using in the rover. Okay. So other things we'll see later in our development of vehicle. So microcontroller I have told already, programming language I have told already. So controlling the algorithm, that is very important when you go for autonomous vehicle. When you are having a control of this remote of your vehicle, then whatever you can do, your brain will do. It should go front, it should go left, right, what all the operation your brain will do. But when autonomous, which brain is there to do? Here the control algorithm is there. Artificial neural network, fuzzy logic. So all these systems are logic. If you say for algorithm, it should be always having a feedback system. Okay, some feedback system will be incorporated. And artificial neural network is a very basic one. Fuzzy logic is very highly used. So now advanced is going on. Okay, this system is also available for image processing. And some of the systems are also available for open source in the library. I will share some of the links for that for you. I will share so you can have that. Maybe some of the examples also there, how it is working and everything. We will see that one. Okay. So overview I have given. So many slides are there. I am not going inside deeper.
If you can do one thing, you just interact with them for 5 minutes,
Yeah.
take their ideas,
Please.
so that you can suggest solutions in
Yes.
the afternoon.
Yes, yes.
Because they are having some issues.
So one video I will show that what I did. So that you sent us in WhatsApp.
No, I didn't. I will send it in the email.
And this not this video, so that the right transparent video.
No, no, I haven't shared anything.
Okay, I just show this one.
I will share all the information, at the later stage.
Okay. So this is system developed by me. So what I will say this how I developed it. I have some presentation. Later stage we will have it. And also, okay, shall I have interaction, sir?
Yes, please.
Then you start.
Yes.
Okay. So any doubt, please let me know. We have interaction of this one after this.
So most of the students are in the master's program.
Okay.
So if you can suggest them which kind
So
of
you want
sensor they
something
can-
where how
Yes.
it can be used,
Yes.
where which sensor can be used. We have this kind of condition. What can be used like that? We can.
We will go one by one, huh?
Yeah, this is
Uh,
no problem. This is comfortable for me. Please, this is
In
Yes.
some fruit crops or fruit orchards, we want to develop some kind of early disease detection system, which is sensor based.
yeah.
Maybe so that can help us to detect the disease earlier, so we can go for sprays or any other thing what we want to do for that. And it should also give us some kind of feedback. What should we do? Like we can program such things in that. Like this is this disease, and you have to spray a particular chemical
Yes.
like that.
Very good question. This is very much needed.
She has also 2-3 questions. Identification of the disease,
Yeah.
then application
For
of the
all the
remedial
things,
measures.
there is a
Yes.
one solution.
Yes.
I will tell that one. So of course that is a project, one kind of project. I can tell that is very good question. And this thing has to be addressed for all the crops, not only for apple, but it should be addressed for all the crops. So what happens once the disease is affected? There are two kind of things maybe in the confusion. There are 100 kinds of disease, right? We are having fever. We are having that may be a different kind of. Somebody will tell this kind of virus, that kind of virus. The first initial thing is has to be trained. You have to take the photos with the experts. So it should be trained. Okay. So for example, each training you should need at least 100 photos. Minimum, I'm telling. Minimum, I'm telling. If the number of photos is increased, means the accuracy will be very good. And your accuracy start from 60%, even you are having 100 photos. Based on that, you should first identify how you are calibrating. Similarly, you have to identify and feed it. So this kind of further sensor should be a camera sensor, RGB sensor, hyperspectral sensor, thermal sensor. And this selection is based purely on by trial and error method. You can have or some research which they have done. Some plants, some insect is there in the fruit, they will emit some temperature. Okay, by using thermal sensor, you can have that. Right? Understand me? So hyperspectral sensor, it will go passes through the fruit and it will show something is inside. And for sound sensor, it will give some sound effect. You are having some problem, they will be having ultrasound, right, in your stomach or somewhere. So there will be some obstacle. Similarly, you can send some ultrasonic sensor. You can find that there is an insect or something like that. So these are another kind of sensor. And the hyperspectral I told, and camera based on color, shape, and like that you can have it. These are different kind of method. We have to select it. So based on that, you have to feed it with the export. So this is based on this. Once you have done this, then you can make it an open app. So anybody can take photo, and the solution for that will be given. Feedback will be given to the farmer. Okay. So yeah, please. Any doubt in that? Any you want anything other? Yeah.
So it was identification of the disease. For example, we want to identify which disease, and the early disease detection. That a disease is going to come.
Okay, whatever the photographs you will take.
When there are no visible symptoms on the plant.
Okay, there is no invisible symptoms. We can have a understanding with the environmental condition, because you are going to have the disease, right? So that you can understand by knowing the environmental condition. By that way.
This will be a kind of prediction based. They are predicting. So whatever size sir suggestion, you have to take the photograph. You have to train the model first.
Yes, that is the only area.
पास्ट के जो भी अवेलेबल होंगे ना आपके पास
So that is how
वही
research
करना है
goes.
train के लिए.
Okay, we'll go to the next problem.
Yeah.
Please. Next.
So that
Huh.
pneumatic plant feeder
Yeah.
is commercialized.
Two types are there. One type is commercialized, the drum type pneumatic sealer, right? That is commercialized. Company is doing that. They are selling.
The one which you showed is commercialized.
Two sold, right? One is that small kind of thing, only the small photo. Another one is big one. One company, right? That one you are asking. Yeah, that is commercial. That is commercialized.
What is the cost?
It is costing nearly 2.5 lakh something. 2.5 approximately.
So one who is running a nursery can use it. It is beneficial for him.
So you are telling that nursery, that suction type system.
Pneumatic plant feeder which you showed me.
That.
First put the seed, then put the soil. The one who is running.
Yes, sir. Jet three types is asking.
Which one? Right, is very less cost. Very less cost. You do by yourself. It is very good, but it is not commercialized.
That was a trial experiment. On the basis of that, they have developed vacuum planter. Na?
You can try
It is
it.
beneficial for them, the one who is running the.
Definitely beneficial. That's why I am showing to you. That's why you are asking. So you can think it's still advanced machine.
Vegetable science, you must be having many questions, please. Problems to both sides.
Sir, like there is controlling of irrigation. Like, is there any way that I am irrigating my field, controlling the irrigation by sitting in my room only?
Yes, it is commercially available, but still for research purpose you can go with advanced systems. How I am telling is sensor network you can make. Inside the sensor network you can collect, but it is not commercially available.
नीचे field में
Even from your, I have seen one person who is in America, he is controlling his field irrigation from there with his mobile.
So like you said, it's like an example of banana, like so we put a sensor which will show us the maturity or whether it will rot or not.
Yeah.
So can we, is that economical? Because what is the cost of
Definitely it is economical. Definitely it is economical. The main advantage sensor now penetrating, you know why? It is very low cost. Okay. That's why it is under the second advantage I didn't told that the second advantage is very small size comparatively. You see some other. This is the main advantage of that. It is saturating everywhere. And the only thing what we have to do is we have to select according to the sensor. And once you did with the sensor, it can be upscaled like anything. There is so many sensors. That's why we are going with Arduino. We can take a high-end microcontroller to do anything. For any research, anywhere you can see that they will be using Arduino Raspberry initially. After they will go for PLC like upgradation. So development should not be just with so many things. It should be started with simple things, with available things. So that's why most of the project starts with Arduino. Okay. Arduino and Raspberry. So of course, yes, it is economic, very economic. You can try with something, with some vegetables. You take the gas sensor, you try it with your bottle. That's why I'm telling you, you can do the similar type to touch-free system. We didn't start just you are playing with that. It is there, what to do that. It is of course available, but we didn't start. It will catch like that. Question.
इनका सब क्वेश्चन है कुछ.
Please ask, please, anything, please.
हिंदी में भी थोड़ा बोलो.
Don't worry, please. You can ask any question.
तमिल
Even if it is irrelevant.
तभी भी हिंदी थोड़ा आता है.
So they want to ask, can we have advanced packaging technique using sensor like that seed picking sensor? जो आपने दिखाया था single one.
Yeah, advanced technique we are having.
So we can use packaging sensors for. Do we have
For
any
packaging
sensors for
purpose.
packaging purpose?
Packaging purpose you are
Probably they
asking.
want to detect and then pack. So do we have?
We don't have sensors, but commercially it is available. Commercially it is available. I will share you that company and also that video.
Sir, can we identify plants on a field which are not healthy and not sufficient and not capable for good productivity and good productivity and yield?
Yes, of course, you are a very good question. So similar like that answer, na, it is applicable. We have a surveillance. Okay, generally I am not coming to drone, but for this purpose, especially drone can be a good option because we will have a result in spot time. Anytime you can fly the drone and have a result. because in ground vehicle it may be taking time for rounding and going and other things. But the drone cannot handle so much of content of capacity, but ground vehicle can. Both has advantage and disadvantage things. Right? But for your question, the crop scouting or disease infection, the drone is the best option. Anytime you can fly it, and based on this maturity, we are having some graph growth, height, the tiller, and other also the color, shape, and based on that, we can understand that. Any practical agronomist can easily understand with using this one. Yeah. Yes, any more questions?
Okay, I will ask from the stable side. In your soil, there are different microbes, different types of microbes. Do you have any sensor to check the type of the microbe or the quantity of the microbe in that soil?
So far, I not.
Because I remember one of the scientists was asking. So
I'm not working so far on that, but I will check and inform you. Okay.
Do you have any other question?
Sir, in storage places like godowns, we are keeping contents of seeds for years, for 2 or 3 years. So it's very difficult to see the prime insects or second insect storage pesticide. How will we come to know earlier, sir, that infestation is so deep? Any sensing mechanism is there which can help us to tackle infestation?
Okay, I understand. This is a very big problem. Very good question. Actually, what happens when the insect present, what it will eliminate some carbon dioxide. We should the insect will eliminate some gas. Based on the gas amount, we can have there is a infection. One reason. Okay.
Or even the temperature?
No, one thing I am telling. Okay, that is the main one. And the second one is your temperature. Even your thermal sensor, you can understand there is an infection in the system. Thermal sensor, it will detect easily your insects or anything in the system. So anyhow, it starts from spreading, it will be visible to the based on heat. Understand? And third one, the hydrospectral camera also be used for the system, where different band will be displayed there based on the wavelengths. So that can also be taken up, and there are so many things. But why is this system so far not adopted? And there is a big questions are there, and still they are working on that. Again, the ozone system is there. My friend Dr. R. Pandit Chelvam, maybe you have heard, he is 2% of scientist. He is my batchmate. Ozone applicator he worked. Still he is working. That is very good for storage preservation. So ozone can be gas can be sent and it can be kept. It can be increase the life of the this grains. Okay. So my thing is this thing: gas analysis, temperature, hydrospectral. We can use 3 systems to understand. So of course I am not working on that field more, but what I have learned and understand is this system can be worked.
Anything else?
Sir, what are the advanced packaging techniques in case of cut flowers? Like gladiolus, as there is the geotropic bending after harvesting.
Actually, I don't know this.
They are actually asking this floriculture is having issue of this spoilage. So is there any process to detect the spoilage or even apples? So whatever the sensor we are using for banana like for apples, similar can we use it for floriculture?
Yeah, it is used, but I am not having deep understanding on that. And what way I can explain you? Because what way the return can come, spoilage, whether it is gas or temperature like that, I am not having idea.
Okay, I don't think we have any more questions.
Just one more question.
Okay.
Can we have the sensors for the determination of nutrient content of the fruit product?
Yes, there is a sensor. It's commercially available, but not for all. There is so many things. Some of the thing is that it is also available in our university, which where I studied. I have seen that. If you need, I will send the detail of that. Okay, but I am not telling for all. But there is a limited nutrient content available. Sensors are available. Similarly, like our soil, we can have some of the things, not all the things like that. Some of the things you have to do process, then only you get. There is no other way.
Okay, with this, I don't think we have any more questions. This is probably for the first time I have seen an expert replying to almost everything. Almost all the questions we have done. And I think we have done very good job of keeping his lecture at the last stage, because he showed us how to convert the innovation into money. That is what entrepreneurship is all about. He sold those items, sold 1,000, 2,000 pieces, and he earned the money. That is the main purpose. So thank you.
Thank you very much. Thank you.
So we'll be meeting at 2 p.m. today.
So now
for
introduction is
practice.
there? No.
He will be coming up in the afternoon.